Hi, I am Nikolay, CEO and co-founder at Coroot, and today we're going to talk about data. Data AI needs to help us to troubleshoot database performance issues. Before we start, a few words about me. I have a SRE background, former head of infra at pretty big company, and now I am co-founder and CEO at Coroot. We build open source observability platform that turns telemetry data into insights. We try to help engineers troubleshoot efficiently and like found root causes even for complex outages. You can check out our project on GitHub. Let's go. So everyone knows that running databases in production is always hard because databases are stateful. Like if your project growing, the amount of data continuously grows. The second thing is that, like in general speaking, databases has unpredictable load because SQL allows you to query data in many different ways, efficient ways, and inefficient ways. And every new change in your application code can bring inefficient queries. And for example, if you serve users on the internet, you can encounter increased load anytime. And database themselves are complex piece of software, so they have many nodes, many components, many subsystems such as indexes, locking, buffers, caches, and like replication, write-ahead logs, and so on. Many parts that works together, and to be an engineer who can solve any problem with database, you need to know a lot about their internal stuff, to be able to navigate through telemetry and so on. And in big projects, usually databases are shared resources. Many services, many applications use databases concurrently, and then queries they generate compete for resources, compete for logs, compete for disk IOPS, and so on. And now, since our conference is about AI, and we are talking about how AI and LLMs can help us with databases, day one, day two operations, let's talk about LLMs. LLMs are smart. Smart, it's not about, I believe they have, intelligence, but they smart because they have pretty wide general knowledge. They know and they have compressed information about databases. And to feel it better, imagine an experienced PostgreSQL DBA who has immediate access to any documentation knowledge, any information from mailing list discussions, like discussions on Reddit, and you have instant access to any information you need. So I would call it, and I believe in industry, it's called general context, where we know how systems are built. And this knowledge is not about our current state of our systems. And we will talk about it a bit later. And to be able to extension like abilities to LLMs to help us, there is a new things called MCP, Model Context Protocol, that allows us to provide LLMs with additional context. For example, we can integrate some MCP server allowing LLM to query our database. For example, we can define some functions and explain in plain language to LLM how to use them and when to use. And LLM will decide when and how this some which input data we need to call this function to get understanding of our current context. And like in our task, we can imagine like we provide an LLM ability to query our database system views to understand what's happening, what went wrong, and how to fix it. And it can, for example, you can provide them context like, I have a performance issue right now. Here is my database. Try to figure out what's wrong. But the question is like, would that work in real life, real scenarios? And the only correct answer here is nobody knows. Just because it heavily depends on the current state or current context we can provide to an LLM. So it's like LLMs has like broad general knowledge, but we cannot use it to troubleshoot any possible failure scenarios. And to understand that, we cannot measure it because we cannot reproduce all the variety of failures, but we can imagine few scenarios and situations where we can ask our super experienced DBA who remembers everything to solve real world issues. And let's run this one of these thought experiments. For example, we have an OLTP PostgreSQL database under pretty heavy load from our applications. And we noticed that something went wrong with query latency. And we have a pretty big and powerful LLM, and we ask him to find the root cause and suggest us possible fixes. And before we go to the LLM part, let's imagine possible causes of this issue. Like we are an experienced DBA, and we want to find the root cause. There are many ways and many scenarios how performance and query latency of our database can be affected. It can be CPU contention caused by another app on the same machine, another query that consumed all the CPU time, or another query that created additional load to our disk subsystem, or even on bare metal, your CPU can be like thermal throttled by the Linux kernel because of some failure with cooling in your data center. A lot of possible scenarios, and like without any context, it's nearly impossible to understand what's happened in these particular scenarios. And since we imagined all the ways, all the possible root causes, let's think about context in data that we provide to our LLM. And most likely, we understand that providing is with only access to your database and system used, most likely LLM will fail with this task, with this issue, and every experienced DBA because of lack of information, lack of context. For example, when we deal only with PostgreSQL system views, such as pgstat statements, pgstat activity, they don't store any historical data, so we cannot compare even latency, query latency. We can only understand the current latency because we can calculate it, but we cannot compare where the degradation has started, and it's like it makes it much more challenging to understand what's going on and what's wrong. And additionally, when we thought about possible scenarios, there were many cases where the PostgreSQL, our database, were affected the system level, and PostgreSQL itself doesn't provide any information about system, load, other processes on the machine, and so on. And also, like potentially, our problem can be resulted like from our configuration changes or application code changes, and like having only access to database itself like doesn't allow us to understand the cause. And we need to get back to the data, and because everything starts with the data. And now let's think about what kind of information we would need to troubleshoot this scenario. And we need not only Postgres specific and database specific metrics such as QPS, latency, per query statistics, and like metrics describing internal state and internal runtime in database, but also a lot of system metrics and configuration change history. And like we need to gather a lot of data, and then we can use it manually to troubleshoot manually, and like just looking at some dashboards, or we can offload it to an LLM and ask it to find the root cause. Now about gathering data. Usually when we talk about gathering metrics or logs or traces, uh, many engineers think about, setting up something open source or ready-made, for example. Okay, to gather system metrics, I need to install Prometheus and Node Expert. If you deal with containers, most likely you will install CAdvisor. For Postgres, there is a PostgreSQL of like official PostgreSQL exporter for Prometheus, but in the end, you will have only basic metrics like CPU usage or like disk IOPS or something like that. But it will not allow you to understand, for example, complex Postgres-specific metrics because, with PostgreSQL exporter, you will have the number of commits or rollbacks, the total number of PostgreSQL connections, and so on. It's not enough, and you will need to set up something that provides you with granular and precise metrics about per query statistics such as per query latency, per query EO time or CPU time. And having this precise and granular metrics is always a challenge because it's always a trade-off between metric cardinality and efficiency, or cost and accuracy. For example, most likely you don't want to have the statistics about each individual query just because you will need to store tons of statistics, and most likely you will not be able to analyze it properly because of the amount of data. And on the other hand, most likely you want to know about each query group of how similar queries perform, their latency, the number of queries in each group, and you need to understand like new patterns, like new type of query that appeared with this application release, and so on. And it's like always a trade-off. And like understanding situation of the market, I understand that like everyone wants to analyze data with AI, but developing and building data collectors is boring, and it's a tricky task because you need to care about performance, you need to care about that your agent is not affecting other applications and so on. And at Coroot, we cover both, like gathering data and analyzing data. But on the market, you can see a lot of companies that just provide you with MCP server accessing with your PostgreSQL system views and some LLM trying to figure out what's going on. And here is my basic set of metrics about PostgreSQL. So what's usually missing in open source exporters and even in proprietary telemetry agents such as Datadogs and New Relic. First of all, you need to understand the load, current load on your database, such as the number of requests per second. Next, you just need to understand how your database performs in terms of latency. For example, if you served majority of queries in 10 milliseconds, and now it's like 50 milliseconds in terms of database latency, it's a huge difference. And you need to track it and be able to compare before and now. Next, you need to understand the number of connections broken down by their state and queries. Something like performance insights in AWS or DS, where in each point of time you can understand the number of queries in active state, the number of queries waiting for some logs, and so on. And also, you need to be able to explain which queries created significant load in your database in each point of time in terms of CPU time or IO time, and everything about logs. I clearly understand that this set of metrics doesn't cover many PostgreSQL subsystems such as replication checkpoint, write-ahead log, picture writer, and so on. But when we deal with OLTP databases and we need to take care about latency and stability of our database performance, this set of metrics will cover over 80% of possible issues, and even slightest performance degradations can be explained with those metrics. And the good news is that you don't need to implement the gathering these metrics. We already covered this with our Coroot PG agent, which is Prometheus compatible exporters. You can use it with Coroot, and in this case, you will have everything from gathering to dashboards and analysis. Or if you want to use these metrics with your Grafana, for example, and your Prometheus stack, you can use just our exporter and connect it to your PostgreSQL database. And here is PostgreSQL dashboard that contains answers. And for example, I reproduce some performance issue where database latency was affected. And using these simple dashboards of 7 charts, we can explain and understand what's happened. Here we can see that latency spike. Here we can see the total query time increased, and we can see that our usual queries were affected. Then we can see that some of queries consumed a lot of I/O time. And this was alter table articles, blah blah blah. And the majority of connections were in active state, and they waited for a log. And we can see the queries that waited for a log. And also we can see the query that held this log. And like it's pretty easy to understand that we just run schema migration on under the load, and it affected our OLTP queries. And like this is pretty simple to understand for any DBA and even for developers. But since we are talking about AI, let's just run a simple experiment and just show this dashboard to ChatGPT and ask him to find the root cause. And it works because, our data, our context, plus general knowledge by the LLM allows us to understand that the alter table impacted our OLTP queries, and it's like understand what's happened and explain us why it's happened, because this query takes exclusive access log on the table, and other queries cannot be executed until this log is acquired. And the ways how to fix it, and like don't run this alter table like straightforward way, and apply some DBAs and PostgreSQL, that dark magic, to prevent table from being locked. And also using this data at Coroot, we also perform AI-based root cause analysis, and we ask Coroot to just analyze the data. It doesn't work using screenshots. Instead, it provides LLM pretty general context and understand what's happening. But we ask LLM to provide us immediate fixes. What we can do right now to remediate our production incident. And in this case, the only way to stop it is cancel alter table. And it's like in this context, from my perspective, is only correct answer, because how to perform this alter table efficiently without affecting our production, it's like task for tomorrow, not right now. And if needed, Coroot can provide additional context and set of evidence. Like that's it. As you can see, LLMs are powerful enough to help us with troubleshooting, even in complex scenarios, but we need to provide them with a pretty precise context, and like providing only a few MCP to our Prometheus or to our PostgreSQL database or other database, most likely will not be efficient. And like, I prefer to think about it as, if you can find the root cause using your data, LLM will also be able to do so, just much faster. And the opposite scenario, where you provide nothing about current situation, current scenario, LLM will just suggest you to check this, check that, and it will not be a precise answer and the root cause. So if you want to offload some troubleshooting steps to LLMs, you need to think about data you provide. That's it. Thank you.